Welcome everyone. Today we are going to present our project titled Washing Machine Application of Embedded System that we did in the internship from the Emertxe Information Technologies. This project is presented by Bandalapat Nikhil, Palankot Kushwant, Mokaraj Yogeshwar. This is P. Kushwant going to start the PowerPoint presentation of the project implementation and explanation demo. Firstly, let's see what we learned during the internship. We gained valuable experience and knowledge in both programming and hardware domains. Here are the key concepts that we learned during the internship. Basics of C programming and introduction to the C programming, such as conditional loops, operators, arrays, pointers, functions, strings and storage classes, and introduction to embedded system and prerequisites of the embedded system and microcontroller. Hands-on experience with the softwares like MPLab, XCB and PixieLab tools. Introduction to various peripherals of the PIC16F877A microcontroller, that is a specific kind of microcontroller that we used in the project as well. And introducing various peripherals of PIC16F877A and other related quizzes. Let's see what are the contents that we are going to cover in this demo video. Firstly, we will see introduction to embedded system, components of an embedded system, and embedded programming, and finally the project, about the brief introduction to the project and the project implementation demo. Now see introduction to embedded system. An embedded system is a small computer designed to perform a specific task within a larger device. It typically includes a microcontroller or microprocessor, software to perform the task, hardware components for sensing and actuation. Examples of embedded system include washing machines, which is our project, and traffic lights and smartphones, micro ovens, etc. Basic definition to embedded system is: an embedded system is a combination of hardware and software. Here we can see the images: industrial robots, GPS receivers, digital cameras, DVD players, and many other examples for the embedded system. And now see the components of embedded system. We can say input ports, output ports, memory, system core, and other devices are the main components of the embedded system. Let's discuss the main functionality of each component. Input port is used for mainly sensors and other user inputs are used as input ports to detect the input. To control actuators and displays, etc., are the output ports. To store the code, which is programmable, is stored in the memory. Memory is used to store the code and data. Other devices such as communication modules, timers, etc. And the system core, it is the main processing unit, like a microcontroller or microprocessor come under the system core. Let's see the components in detail. Firstly, system core. The system core is the brain of the embedded system and includes which may be microprocessor and microcontroller. Examples for microprocessor are 8085 and 8086, which are Intel belongings used in general computing tasks. 8085 is a 8-bit microprocessor and 8086 is a 16-bit microprocessor. Coming to microcontrollers, ARM, which is abbreviated as Advanced Disk Machine, DSP, Digital Signal Processor, 8051, and PIC, Peripheral Interface Controller, are the examples for the microcontroller. Microcontrollers are more suitable for embedded system due to their integration of CPU, memory, and peripherals. A microprocessor is simply a CPU, but whereas the microcontroller is the integration of a CPU, memory, and peripherals, so microcontroller is more suitable for designing an embedded system. Coming to embedded programming, Embedded programming refers to writing software for devices with limited resources. It is low-level programming often done in embedded C. It focuses on hardware control, including sensors, actuators, and microcontrollers. Efficiency, speed, and real-time execution are crucial in embedded programming. It is a low-level programming. So these are the popular languages that is used for embedded systems for writing code. Next, coming to differences between normal C programming language and embedded C. C is a general purpose language used for developing software, mainly operating system that we know. OS are developed using the C programming language, while embedded C is specifically designed for controlling hardware in embedded systems. Using the embedded C, we can control the hardware components of an embedded system. Coming to C, C runs on computer with operating system like Windows, Linux or Mac, etc. C programs have more memory and processing power available. Coming to embedded C runs directly on hardware, which are, as we discussed, microcontrollers without an operating system. Embedded C must be optimized for small memory and low power usage, as embedded devices have limited resources. Coming to introduction to embedded C. Embedded C is a specialized version of the C language. This is nothing but a C language with a specialized version. It is a specialized version. Used to write software for embedded systems, allows direct hardware access, can interact with components like sensors, displays and actuators. It is simple, efficient and suitable for real-time operations. And then coming to key features in embedded C. Embedded C uses standard C syntax include loops, conditions and functions. Direct hardware access, can read or write from hardware registers. No standard libraries. Functions like printf, scanf, these cannot be used. These are avoided actually. Efficient memory usage. Code is optimized for size. Real-time processing. Critical tasks are performed instantly. And then the rest of the PPT or the PowerPoint presentation is explained by my fellow teammate Yogeshwar. Thank you.
Hi everyone, I am Yogeshwar. Now I am going to tell you about data types and variables. Embedded C uses a standard C data type, but they are optimized for embedded system with limited memory and processing power. It also includes the hardware-specific data types that interact directly with the microcontroller registers and memory locations, which makes us the reaction time is very higher and which makes it is easier to use in real-time applications and uses in a very wisely of memory locations. Where data types is divided into two types of basic data types and derived data types, where variables are divided into again two types, local variables and global variables. Here are some examples of basic data types and derived data types. Basic data types are int, char, float and double, etc. Whereas derived data types are array, pointers, structures and unions, etc. Here basic data types are independent of any other that that we use and initialize some element to a variable, where derived data types are derived from the basic data types, where for example take an array. An array element should be, all elements should be in a single data type, like if all should be an int or all should be in a char, etc. And next we move on to the PIC microcontroller. As we use this microcontroller for various applications of washing machine, etc., simulations of the PIC microcontroller, we have various versions of PIC microcontroller. Among all these, we use an PIC 167877A. It is an 8-bit general purpose microcontroller which includes the RISC, flash memory are the key features of PIC microcontroller. Here is the architecture of an epic microcontroller. As we see that the arrows are pulling out and inward, which makes us some confusion. Let me clarify you. The arrows which inward and backward to a single block, which makes it is a bidirectional block, whereas a single arrow indicates whether it is an input or an output. Let's dive into it. Let's see that RS232, which is in a bidirectional, which takes the input from the microcontroller and gives output to the microcontroller, where LED just gives an output and buzzer takes the given to input to the microcontroller. Likewise, the matrix keyboard, which makes both output and input, and I2C, RTC, and EEPROM, which is in a memory location outside the microcontroller, which gives us both bidirectional, and the temperature sensor, like these are being a single input devices. I think you all got an idea about the architecture of an PIC. Now coming to the pin diagram, as I discussed in the architecture, here also the in-depth pin configuration of the pin diagram. As we see that there are many pins that are associated with it. There are 40 pins in microcontroller, PIC microcontroller. As we see that there are mostly so many are multiplexed with the read and write and digital pins or etc. As you see that 32 and 31 are VDD and VS, as same as the 11 and 12 as same VDD and VS. There are various clocks and as we used in this. Now coming to the peripherals of microcontrol that we used. A CLCD display, a character LCD is simply a digital screen used in embedded systems as shown in the text, numbers and symbols. If you want to know how it is work, receives the data from the microcontroller and process the data and display the data. As we see here, we maximally use the I2C protocol, which makes it is better suitable for the displaying purposes. And peripherals of microcontroller, that we use a matrix keyboard which has to give the how to wash the clothes in different modes. That's why we have put it in a keyboard that makes us the buttons. Matrix keyboard of a keypad with the multiple buttons arranged in rows or columns to reduce the number of required inputs. It is commonly used in embedded systems, calculator, ATMs, security system and industrial controls. And now I am going to tell about a brief intro about how we are going to be dive into this project, about the project. In this project, we are going to simulate a washing machine, which is known popularly an application of an embedded system using PICSIMLab. What is a washing machine? As a basic question that we all know, but I have to explain it to you. A washing machine is an electrical household application that is used for cleaning and clothes using detergent and water. It has different modes of operating such as wash, rinse, spin, and may include special settings like quick wash, heavy wash, delight, drying, depending upon the type and the model. And coming to the exactly what's going on in the washing machine application. A washing machine is an everyday household application that uses an embedded system to automate the process of cleaning the clothes. As we see in this picture, there are various buttons, so we use a matrix keyboard for that, and a display that we use in CLCD display, and the motor that we use in a pick microcontroller to adjust how to do it, and there are some RAMs and control unit. These are also taken care of pick microcontroller to what have to be done, and their prefetched data locations are stored to how to perform a specific task. Unlike a traditional washing machine, modern washing machines are equipped with the intelligent electronic control system that manages all the functions with a precisely and efficient way. As you see that today's washing machines are automated because of these automatic microcontroller. They will take in a feedback from it and does the work in very precisely form. So that's all my set, guys. The code will be explained by the Nikhil, and thank you.
Hello everyone, I am Bondalpat Nikhil. So let me continue the presentation about the washing machine which we made which we made during our internship period at Emertxe. So let me explain the code using MP Lab. So as you can see, these are all the header files we used for the washing machine, and the source files, which are C files, are also used. So there are various header files including CLCD for the LCD display, digital keyboard for operating the keypad in PiximLab, timers for the timing purpose, and the main header file to coordinate all this, and source files CLCD, digital keypad, and also you can see the main C file which is used to control to coordinate between everything, and it is the main code. So let us explore the code. As you can see there, this is the timer control code, and this is CLCD used for displaying LCD. Now coming to the main C file, as you can see we started with including main header file. Next we explore the various functions of washing machine program, which are daily, heavy, delicates, whites, stain wash, eco cottons, woolens, bed sheets, resin and dry. And also after selecting any of the options, we can go into the next step where we select water level: auto, low, medium, high, max. So you can select one of these options as your water level, and after that we let us explore. As you can see, the CLCD print functions are used. Press key 5 to power on the washing machine, which is displayed in the LCD in the PiximLab, and it indicates when button SW5, which means RW4 in PiximLab, is pressed, the washing machine is turned on. And SW5, as you can see, we also assigned pause and start. As you can see, we also assigned start and stop options to SW5 and SWT6 switches, which are used for starting the function and stopping the function. And all this code use it for the displaying of the function which happening in the washing machine. So when SW5 is turned on and it is start, the fan starts rotating in PiximLab, which indicates the operating of washing machine. While it is operated, a timer for the operation is displayed on the CLCD. As you can see, these are all the switch cases to select various functions and water levels in the washing machine. And this door status check function. So we assigned RB0 with the door open option. So when we press this button, the door of washing machine is opened and buzzer is on, and also the fan which indicates the operating of washing machine is turned off, and function also turns off, and timer passes, and LCD displays door open and please close. So the operation only resumes after we close the door. So when we close the door, you can see the fan is on and the timer is also turned on. As you can see, the buzzer is on and fan off and timer is off during the door is opened, and it is back to normal when we close the door. As you can see, there are various options: spin and resin. So this is all the code I can explain. So now let us do the execution. We are using PiximLab for the execution. So now let us load the hex file required for this washing machine. So as you can see, we opened the production, and so as you can see, I set the clock frequency to 20 mAh, which is suitable for this program. And now press key 5 to turn on the washing machine. As you can see, I am pressing RB4, which is SW5, to turn on the washing machine. So let me start it. As you can see, it is turned on. Now as you can see, we can explore the various washing programs, which follows by as daily. You can toggle the options by using RB3: daily, heavy, delicates, whites, stain wash, eco clothes, woolens, bed sheets, rinse and dry only, and wash only. So let us do the wash only now. So to start the wash only option, we need to press and hold RB4, which is SW5 button. Sorry, RB3. So when we hold it, it goes to the next option where we choose our water level. So as you can see, we can toggle between the water level options, which are auto, low, medium, high, max. So let me select the water level by holding the same button again. As you can see, I set the water level to high. Now I press SW5 to start the operation, which means RB4. So let us start the operation. So the timer is set to 26 seconds. The function wash is started. So as you can see, the fan is rotating to indicate the operation is begin. The function is presently wash. Now let us open the door. As you can see, when I press the RBO button, the door is opened and it indicates please close. So all the operation we are doing is paused when we open the door. Now let me close the door. As long as I am holding the button, it won't be closed. So as you can see, now I close the door and the operation continues as it is. As you can see, the program is completed. When the program is done, it is again back into the first menu where we choose our function, whether it is wash only or aqua dry or anything else. So again we can choose the option we need and continue our usage. So I thank Emertxe for giving this opportunity and all the training they have provided us during this internship. uh, to improve ourselves during this summer period. Thank you.